Work and energy. Two things that can be alien to teenagers at times. Oh. You need to be able to do this. Work is defined as a force on an object acting over a distance. Its units will be newtons times meters, which is identically equal to a unit called joules. So Newton meters are a joule. This makes common sense. If I drag an object on the ground, I exert force. It makes sense that the distance I drag this object also contributes to my work. So lifting a 10 kilogram object against gravity, I am subject to a 100 Newton force. Lifting this mass by 2 meters means I worked 200 Newton meters, which is called 200 joules. We pronounce this Newton meters, not newtons per meter. In imperial, it is called the foot-pound. You need to get a gut feel for this. Joules and calories are the same concept, energy. You eat about 10 megajoules of food per day. This is around 2,000 calories. So 1 joule is approximately 4.2 calories. So you could sort of figure out a joule is like $1 and a calorie is like a quarter. Calories were originally defined as the energy needed to warm a cubic centimeter of water, about a thimble full of water, 1 degree Celsius. So it takes about 4 joules to raise a milliliter of water 1 degree. A cup of coffee is 250 milliliters. So if you actually took it from ice cold to 99 degrees, then that's roughly 100 degree change. Then you're talking, put 2 zeros here and multiply by 4, and you'll have your total. Here's a simple calculation. This guy's going to lift 50 kilograms of mass. 50 kilograms of mass multiplied by gravity gives us approximately 500 newtons lift he's going to be doing. He stands up 2 meters. So now he's engaged in this force against a distance of 2 meters. So the work he's done in lifting it is 500 newtons times 2 meters is 1,000 Newton meter with the sucky program not showing the dot. We get 1,000 joules. This is the work done on this mass here, not the biological work done by the weightlifter. He did way more than 1,000 joules of work, probably minimum double. You are really terrible at turning your stored energy into useful energy. We're extremely inefficient. It might even be 3 times much more. He had to lift his entire body up. He sweats. When he's standing still, he's still burning energy. But what I'm saying is now these masses contain 1,000 joules of stored energy. If you drop them and they land on your foot, how does that feel? That's what 1,000 joules is worth. The work done is a scalar. Force and distance have direction, but not energy. Think about it. Doesn't make any sense at all to say, yeah, I burned 400 calories northwest today. Tomorrow I plan to eat 400 calories of cake to the southwest. Should kind of even out. No. The work done was on the object. This is the energy used by the weightlifter. Work is a verb. Energy is a noun. You do work and you use energy. So the term work and energy are interchangeable in physics. It's just a question of work was done on this and I used energy to do that. And we are not including the mass of the weightlifter. We're talking about the object itself. Let's calculate his burn. He lifted the mass to 1,000 joules. Let's suppose he just lets go, drops it, and repeats it 50 times. That means he has expended 50,000 joules of energy on the mass. What kind of snack has he earned? Well, I looked up Whippets. and each whippet is 75 calories. So it seems like he may have earned a lot. Because remember, there's 4 joules in a calorie. So that's a lot. Even that is only like 300. He's earned a lot. Oh, what it could be so simple. The calorie industry, the Weight Watching industry lies to you. A calorie in the food industry is actually 1,000 calories. It's a kilocalorie, or 1,000 cals. So when this whippet, the cookie, says 75 calories on the label, they really mean 75,000 calories. So this means when we do our math, we're looking at 300,000 joules per cookie. So you've come nowhere near what you need. Now, I said we're not terribly efficient. We're probably only like 30% efficient. So this 50,000 joules, maybe if he's really going to town on this, he's burned 150,000 joules, tops 200,000. But nonetheless, he's lifted a 50 kilograms set of bell bars 50 times, and he has not earned one cookie yet. This is why diets based on exercise are often doomed to fail, because people overestimate what they can eat after a workout. And even if they know a bit of math, most people are not aware that the calories on these boxes are wrong. They are hiding 3 zeros. Okay, so we'll come back and look at how this applies to vehicles.